All right, so yesterday we covered 2.2, which is graphing polynomials of higher degree. So we went from like parabolas in 2.1 to shapes that we're not necessarily sure what kind of shape it takes. There could be multiple zeros, multiple turning points, all that stuff. So one of the first things that you want to identify from your function is the leading coefficient test to figure the end behavior. One of the easy mistakes to make is not paying attention to the order that your terms are in, so be really careful. A lot of times the highest exponent is first, but not always. So in example 1, the highest exponent is first, but if this was switched around, if this said, like negative 9x, God bless you. If it said negative 9x squared plus x to the third plus 27, it's still the same function, but you got to really pay attention to the order. So again, this time it is in order from highest degree, which means that the leading coefficient that I'm looking at is the one on front of the x to the third term. So the fact that my exponent is odd tells you what? One's going up, one's going down, right? We don't know which one until we look at the sign on the front of it. So because it's a positive x to the third, what does that mean? Good. Falls left, rises right. Okay, then question 2 says, to find the zeros of the function, state whether the graph crosses the x-axis or touches it and turns around at that point. So this is already factored for you. Obviously, the next one's not. We'll talk about it then. If it's already factored for you, you just have to solve it, but pay attention to the multiplicity. So this answer is 1, but how many are there? 2. And this answer is negative 3, and how many are those? 3. So what does it mean to have an even amount? Good. It's going to bounce off. And the odd, it crosses through. So if it occurs an even amount of times, it's going to bounce off the graph at that point, turn around. If it's odd, then it's going to cross through. All right, then 3 says,
How come you would do it like that with squared? So wouldn't you have to do
so this whole thing, x minus 1 squared, would equal 0, right? Like if I was going to solve it. And then when you square root it, it's x minus 1 equals 0, but it's plus and minus 0, which means there's 2 roots. So when you add that 1, there's technically 2 roots there. It's the same thing as saying that this is x minus 1 times x minus 1. There's 2 of them. So you just have to make sure that you pay attention to it for the multiplicity. The one on your quiz is going to be something similar to this where you have to factor it first, so it's not going to already be factored. And it's going to ask you to kind of put all of this stuff together. It's going to ask you to find the end behavior, the zeros with the multiplicity, the x-intercept, the y-intercept, or not x-intercept because that's your 0. The y-intercept, and then graph it with as much as you can. So if I start at the very beginning with this, 1, I want to make sure it's in decreasing degree. It is. The highest exponent is odd again, and the number on the front of it is positive again, which means this will also fall left and rise right. Then I want to find the zeros. So I'm going to take what's here. Usually there's some sort of factoring involved. This time I can actually take out a 2x, and I get x to the second minus 4x minus 16. Nope, not 16. Minus 2. Thank you. 2x minus 8. And then I want to look for the factors of negative 8 that sum to negative 2, which would be positive 2, negative 4. And then solve. So this is 0, this is equal to 0, this is equal to 0, and I get 0, negative 2, and 4. They all only occur one time. So it's going to cross through all those points. So then I go to my graph, and I'm going to start with those points. Negative 2, 0, 4. I know it's going to fall left, rise right. So already I have that information. You with me so far? Mm-hmm. Now, if I wanted to find my y-intercept, I'd plug 0 in for x, okay? But we already have it because we had 0, 0. So that doesn't really give us an extra point, which means I need to figure out what's happening in between these spaces. I know that this has to cross through. I know it has to come back down. I know it has to go down. It has to cross through, go back up again. But you don't know how high and how low to go. So you want to go at least 1 point in between those areas. So I'm going to plug in my negative 1. So I take my function, 2, negative 1 to the third, minus 4, negative 1 squared, minus 16, negative 1. And I get 2, God bless you, times -1 minus 4 times +1 plus 16, -2, -4, +16, and I get 10. So I'm going to go all the way up to 10. Okay, I'm going to go up and come back down because I know it's going to come back down. And then you want to do the same thing in between 0 and 4. Again, it doesn't really matter where you pick it. I tend to try to shoot towards the middle, like maybe 2. But it's not, I just need 1 point somewhere in there. So I'm going to plug in 2 to the third minus 4. 2 to the second minus 16 times 2. 2 times 8. 4 times 4. And I get -32. So this is not on this graph. And this is going to happen to you sometimes on a test or a quiz where it's not on that graph. You don't have to like literally plot out -32. Okay. I know it's really low. And I can just go down and come back up again. And then what you'll do is label that. Okay. I don't need you to go all the way down to 32. But I do want you to plot it, label it, so that you know where it was. So if it's off your graph, you can go by 2s if you want. You can extend your graph, or you can do what we just did, which is like kind of like plot a point, like as though it would be there, but label that point.
Are we gonna have to find a 0 by completing the square?
No, for.
So I think that was my problem, because like I couldn't figure out how to factor, so I didn't know what to do.
So you're gonna have to complete the square, but not to find the zeros for here. Yeah.
Yeah, because like on the homework it says something about the 0, and I couldn't factor it, so I had to like.
So you have your options are complete the square, quadratic if it's not factorable.
Yeah, but if you do quadratic, like, can I give you my, like...
Yeah. God bless you.
I took out...
Yep, that's what I would have done. And then you're like, oh crap.
That would work.
Yeah. So you tried the quadratic, or you didn't want to do the quadratic?
No, I tried the quadratic, so I was like, I don't want to mess with complete the square.
This is actually probably easier to complete the square because it's an even number in the middle, but it doesn't. But
Yeah, but
yeah.
you do quadratic for one.
Yep. So A is 1, B is -4, C is -1, right?
Yeah.
So 5's still on there, but then I would do -b plus and minus the square root of b squared minus 4 times A times C all over 2 times A. 4 plus and minus the square root of 16 plus 4 over 2. And then 20 can get broken down. 2 root 5. So then this goes in here twice. Once this is 2 plus and minus the square root of 5.
Okay, that's what I was gonna ask. So the 2 can go into both the numbers?
Yeah.
It goes into the square root.
It can't, correct. So you could split that if you want to see it visually. That'd be 4 over 2 plus and minus 2 root 5 over 2. And then this is 2, and that's gone.
And then you'd be left with...
So your 2 zeros are 2 and 2 plus root 5 and 2 minus root 5. So those are your zeros, and then if you wanted to graph those, you would approximate this to like be 2.1, so it'd be 4.1, and then -0.1 if you were going to graph it. Yeah, so you'd have to take,
Oh, then what do you do with the 5 then?
because if it's a 0 and you're setting this equal to 0, you could divide or multiply both sides by 5 to get rid of it. It's going to go away. So then you're here, which is actually a really good segue because you're going to have to complete the square, right? So you group them. There's nothing on the front. Take the 4, divide it by 2. It's 2 square, it's 4. So I'm going to add a 4 inside, and I'm going to subtract it from outside. So I've got x squared minus 4x plus 4 minus 5. Then I'm going to square root the first term. I'm going to square root the last term. Take the sign from the middle, put it in parentheses, square it. That equals 0. And then if I want to find my roots, I would add 5. And then square root both sides, plus and minus, and I get x 2 plus and minus root 5.
So could I get rid of the number in front of...
Yeah, if it's just a number. So if it's a variable and you pull it out, that's a 0. You can't lose it.
Yeah.
But if it's just a number, yeah, because you're setting it equal to 0.
Because then you would have to multiply, like, let's say after, you would have to multiply that 2 by 5.
Correct.
Add the other side.
Correct.
So you've been adding 10 instead of 4.
No, because you didn't take, you mean like if you, so if I started complete the square by doing that,
Yeah, if we kept it like that.
and you had already bumped this out, yes. Whatever you did in here, you're going to have to do before you go over here. But you don't need to do that. You can get rid of that 5.
If it's just a number, but if not, you can't get rid of it.
If it's just a variable, no, because then you're losing a 0. But you won't, like that's, it won't be like that because then it's not quadratic anymore. So that might happen on your zeros for your higher degree functions like the 2-2 question. But you're not going to have to do complete the square in 2-2. You're going to do complete the square on a quadratic. So it will already be squared. It won't be to the 3rd. Okay, so let's talk about your quiz. Your quiz, which is tomorrow, is covering 1.6, which was your inverse functions.
Are we have a quiz tomorrow?
Yep. You listen to me though, so I've been saying it since last week, right? You know that.
Yeah.
Surprise. Yeah, uh-huh.
I'm shocked.
All right, 1.6 is inverse functions. So there was 2 kinds of problems. Well, there's a couple of different problems in here. But we started with to verify functions are inverses. So if it wanted to see that one function was the inverse of the other, then you have to do f of g of x, and you should get x, and then you have to do g of f of x, and you should also get x. That was one type. Then there was is a function one-to-one, or does it have an inverse? And this is your horizontal line test. Okay, or the x can't be raised to an even power or in absolute value, because then it would fail your horizontal line test, and then it can't have an inverse. And then came the finding the inverse. If I have points, I just switch my x and y's. So if I had the points 1, 2, 3, 4, 5, 6, then my inverse would be 2, 1, 4, 3, 6, 5. So again, if you're given the points, you just switch them. If you're given the graph, you find some points and then you switch them. From your equation, you change f of x to be y. You switch the x and the y. You solve for the new y. And then the very last thing you're going to do is change the y into f negative 1 of x. It stings to go through all that work and then not do the last step and lose points, so be really careful. You can't leave it as f of x. It's no longer f of x. You actually changed your equation. So you show that it's okay that you change the equation by saying it's a different equation, or the f negative 1 of x. So a question like that could ask you, is it a function? And for the function, remember it has to be like pass your vertical line test. And for a function, the y can't be an absolute value or raised to an even power. Then it's going to say, if it is a function, is it one-to-one or does it have an inverse? And that's your horizontal line test. And your x can't be an absolute value, your x can't be raised to an even power. If it's those, find the inverse. And then you have to go through the steps of finding the inverse. Questions on inverses? Okay, again, that was 1.6, so that's the last thing from the last chapter. Then came to 1, which was all the quadratic stuff. So this is your complete the square. It's just going to tell you put the equation into standard form, and that's what that means. And I promise you there's going to be something on the front, and there's going to be fractions, and you're not allowed to freak out. And then you're going to get asked another question, and it's your choice if you want to complete the square with that one, or if you want to find the vertex using negative b over 2a, okay? So you're going to get asked the vertex. Remember, the h is negative b over 2a, and then you plug that back in to get the k. You're going to get asked to find your x-intercepts or your zeros. And you're actually, the wording there is intercepts. Intercepts and y-intercepts. So this one you're plugging 0 in for x. This one you're plugging 0 in for y. If it's factorable, then you could factor it. If it's not factorable, then you'll use the quadratic. You'll get asked domain and range. I'll tell you right now, I'm going to tell you the answer to a question on your quiz. Domain is negative infinity to positive infinity on every single parabola. Every single one, okay? Don't get that question wrong. Domain for a parabola is negative infinity to positive infinity. And then your range, if it points up, is the k coordinate of your vertex to positive infinity. If it points down, it's negative infinity to k.
What if it's, oh, this is quadratic. Is it going to ask the domain for cubic functions or no? No, it's the end behavior, the zeros, the x, the y-intercept, and graph. Then comes max min. Remember, it has a max if it opens downward, and that's a negative x squared. And the max is just k. It has a min if it opens upward and has a positive x squared, but again, the minimum value is just k. And then axis of symmetry. Is x equals h.
For the maximum, do you just put the number? Or
Yep.
you put y?
Nope, just the number. Yep. So this one, the axis of symmetry has to have the x equals. Okay, if it doesn't, you're going to lose points. Don't do that. It has to have the x equals. And the max and the min value are just your y. So again, 2 questions are going to get given to you in quadratic form. The first one's going to say put it into standard form. You're going to be forced to do complete the square, but then you're done with that. You don't have to graph that one. You're just putting it into standard form. Then there's a second question, which is also going to be in quadratic form, and it is your choice. If you want to put it in, if you're really good at complete the square and you want to do that, put it in to complete the square. That's fine. But then you have to answer all these questions based on it. Your other option is the negative b over 2a, which is probably what I would do because there's going to be a number on front again. Negative b over 2a, plug it back in, get all the other information. Again, if it's factorable, then you're going to get your x-intercepts that way. And if you go to do your y-intercept, remember, this is super easy when it's in quadratic form because it's just the c. It's not the case like that if it's in standard form. If it's in standard form, that last number is your k, which is your vertex. It's not your y-intercept.
Wait, can you say that again?
Yeah, so like if it's in, like, let's just say this is 3x squared plus 7x plus 1, okay? And I asked you for the y-intercept, it's this. That's it. It's 1. It's 0, 1.
Oh, well, what did you say before that?
It's not the same if it's this That is not your y-intercept.
So,
You'd have to plug 0 in. So from quadratic form, ax squared plus b squared, you've got the x squared and the x. Your number that's by itself is your y-intercept because you would plug in 0, this would go away, and this would go away. But in standard form, that's not the case. You'd have to plug in 0, you'd square it, you'd multiply it, and then you'd add it to get your...
so like you're saying, like if it's in standard form.
It's way easier to find the y-intercept that way. Before you put it into... It's way easier to find it in quadratic than it is in standard form. It's still possible, but it's easier. And then obviously you're going to have to graph this, okay? If there's not enough information from your intercepts, then you're going to have to plot extra points. So if there's no x-intercept, you have one y-intercept, you're going to have to plot some points. Because you have your vertex, one y-intercept, you need another one on the other side.
And
Okay?
then you're going to know that it's like...
You should know
of the three.
You should know, oh, like if when you go to graph it? Yeah. That's if you put it in standard form, though. You might not put it into standard form. Yeah. Okay, and then also in this section was getting the equation in standard form. So for this one, you'll get given an x, a y, and an h, a k. It'll say the vertex, it'll say the point. Don't mix those up because it's important. And you'll plug that into y equals a times x minus h squared plus k. You'll solve for a, and then you'll plug back in just the a, the h, and the k. So it will say y equals a number, x minus a number squared plus a number. So the x will stay the x, the y will stay the y, but everything else gets replaced in your answer. And I said it like when I taught it, but don't forget your squareds. That's the mistake people make here. When they're plugging it in, they forget to square it, and when they're writing their answer, they forget.
That's if you're finding what? Like,
That's if you're finding the equation. It'll say, like, find the equation of a parabola that has the given information. Vertex is this, passes through this point, or solution point.
so how would you find that?
You'll have the x, so you'll have, like, it'll say, like, 2, 3, negative 1, 4, right? So if it says this is my vertex and this is my point, this is my h, this is my k, this is my x, this is my y, and I just plug it in. So 4, yeah, that's what you'll solve for. The only thing you don't know is a. So then you've got your a, and then you plug back in your a, your h, and your k.
The HK is the vertex.
Mm-hmm.
So A like your slope.
A is meh, sort of, yeah. It's your steepness or your climb. Questions? So all of that was 2-1. And then 2-2 was what we just did with, right? So 2-2 is the polynomials of higher degree. Mm-hmm. Mm-hmm. Okay, so this is, you're gonna find your zeros, your end behavior, your y-intercept, and then your multiplicity on the zeros. Multiplicity. And then you're gonna have to graph it. So important things is make sure it's in decreasing degree order. Before you determine your end behavior, okay? Don't always look at just the first one. It's got to be the one with the highest exponent. You're going to definitely be factoring. It could be just, like a regular trinomial. It could be a perfect square trinomial. It could be different two squares. It could be 4 terms and factor by grouping. Okay, there's a lot of different kinds of factoring that we went through.
What is decreasing degree order?
Like the highest exponent down to none. So, like I was saying on the warm-up, if you had this, you would want to, you would want to make sure that this is the first one. Yeah. Okay, questions for me as far as quiz expectations. So there's no calculator on tomorrow's quiz. Again, we'll save it for your test. And there's no part 2 from the like whatever wasn't on that video yesterday is not. I'll save it also for your test. Tomorrow is early release, which means you come in, you take your quiz, you're done. Yeah, so you need to make sure that you're like ready to go to come in and take your quiz. You have plenty of time. It's a quiz, but it will take the whole class period instead of usually have a little bit of review time and then you start. It's going to take the whole class period. And then I posted a quiz review. I think I have most of the solutions. I just got to answer a couple. I have to piece together the inverse ones, and then I'll post those today as well.
Yesterday I was kind of confused on like when the graph like it gets like straighter on the
Like flatter around it. You don't really have to worry about it too much. I would just say if you're going to graph something and you see that it's got a higher exponent, then it should naturally be flatter. You're not going to have to be that specific.
And then for the parabola, what was it?
It's the same. Like it's between, like, so if I had an x squared and I had an x to the 10th, right? Then where this would be 0, 0, and then 1, 1, 1, 1, right? Like sort of like that. This would just be closer to the axis in between, because instead of raising something to the second power, like 1/10 to the second power, I'm going 1/10 times 1/10 times. So it just flattens it out there, and then it increases faster past the first point. That's the only difference. But you don't have to worry about it. I'm not gonna ask you to graph the monomial. You're gonna have a big function where you have to find the zeros and all that stuff. So those questions, like especially the second quadratic one and the decrease, and the higher function, they're worth a lot of points because there's so many different parts. I would say be really careful, especially on your quadratic one, because if you get the vertex wrong, now you're getting the axis of symmetry wrong, you're getting your min and your max wrong, and you're getting your range wrong. So be really, really careful, because that'll feed down into wrong, 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 wrong. Okay? Be really, really careful.